Welcome to this Maths Made Easy video on trig equations. And to start with, let's take a look at the method of inspection here. Now what we've got presented in this diagram here is the equation y equals tan x. So let's note that first in red. So we have y equals tan x. And we can see that here, this is represented in this red curve here. However, we notice we have a few of these. For example, we have one here, one here, one here, and one here. And the reason for that is because tan x is periodic about 180 degrees or pi radians. So what that means essentially is that tan x repeats every 180 degrees. So in that case, depending on what we're looking for here, we're going to obtain multiple solutions. So if we want to solve here, tan x equals 1 over the square root of 3. Okay, so 1 over the square root of 3. Well, 1 over the square root of 3, we're going to represent using this purple line here. Okay, so 1 over the square root of 3 is represented using this purple line here. Well, like we can see, we obtain a few solutions here. We obtain this solution here, where 1 over the square root of 3 intersects with tan x. And again here. And again, we're going to have one down here. We have one here. And again, we have this one here. Okay. So, how can we use this idea now of where tan x intersects with 1 over the square root of 3? If we want to solve tan x is equal to 1 over the square root of 3. Well, in that case here, we can simply identify this first solution here as being 30 degrees. So this first solution here is 30 degrees. Okay. So what we say here, so we just change back to our original pen colour, is that the initial solution is 30 degrees. Okay. So our initial solution is 30 degrees, and we know tan x repeats every 180 degrees. So what that means then is my next solution here will be 210 degrees. Okay, my next one here would be 210 plus 180 degrees, and then we would repeat that here in the negative. So this is going to be minus 180 plus 30, which means that's minus 150 there, for example. Okay, now we can simply repeat this then using the fact that this is multiples of 180 degrees. So therefore, our solutions here, solution here is going to be 30 degrees plus 180 degrees times by n. Okay, and that gives us our solution there, to tan x being equal to 1 over square root of 3 using inspection. Now moving on to cast diagrams. Now cast diagrams are a useful tool that we can use when we're looking to solve trig equations. So what does a cast diagram look like? Well, we can see here from this diagram, this is what a cast diagram would look like. So what does this represent? Well, what we say here is between 0 to 90 degrees, this quadrant here, all of sin x, cos x, and tan x are positive. So we write this out in full here, therefore from 0 degrees to 90 degrees, all of sin x, cos x, and tan x are positive. So therefore sin x, cos x, and tan x are positive. Okay, and that's what the A represents. That represents all. Okay, so they're all positive. So now if we move from 90 degrees to 180 degrees, what's going to be positive in this quadrant? Well, we use this idea here of the S. So in this quadrant here, you might have guessed it already, only sin x is positive. So in that case, 90 degrees to 180 degrees, only sin x is positive. Okay. Now moving from 180 degrees to 270 degrees, well, we have this represented by the t here in this quadrant. And again, you might have guessed this represents tan being the only positive solution here. So only tan x is positive. So 180 degrees to 270 degrees, the then only tan x is positive. And finally, moving from 270 degrees back to 0 degrees or 360 degrees, then in that case, only c is positive, and in that case, the only remaining one here is only cos x being positive. So, from 270 degrees to 360 degrees, back down to 0, depending on which way you're thinking of this, then this is represented by only cos x being positive. Okay, so only cos x is positive there. And you can think about this using the unit circle that we covered in the trig basics section. Okay, think about this as a unit circle here, then clearly the trig functions that are positive on these quadrants here is clearly linked to the unit circle. Now let's think back to the example that we've just done here for tan x being equal to 1 over the square root of 3. So tan x is equal to 1 over the square root of 3. So here now, we're looking to find our solutions here. Now we already know the initial solution. So in this case, the initial solution is x equals 30 degrees. Okay, we know that's our initial solution there. Okay, and we can represent that here on our cast diagram. Now, looking at this first here, we have 4 quadrants. We have C, A, S, and T. However, as this is for tan x, we only want the positive solutions here. So in that case, the only 2 that we can possibly use here is in the A quadrant here and in the T quadrant. Remember, tan x is only positive in the A quadrant here and this T quadrant. So, using this then, we can clearly see that our solutions here lie. So if we just clear everything on the screen now, then in this case here, that tan x is equal to 1 over the square root of 3. So we just write this out in full. So tan x is equal to 1 over the square root of 3 here. Clearly, when x is equal to 30 degrees, plus or minus 360 degrees, plus n, so 1 full revolution essentially. So plus or minus 360 degrees times by n. Or 210 degrees, represented by this angle here, that's going to be 210 degrees, plus or minus 360 degrees. That's 210 degrees, plus or minus 360 degrees, times by n. Okay. However, we could write this more concisely as 30 degrees, so more concisely here. As x equals 30 degrees plus or minus 180 degrees times by n there. Okay. Notice we omitted the negative solutions here, where tan x, would not be positive. So in this quadrant here, we didn't want that one. We didn't want this one here. So notice we omitted those, and that's how we used our cast diagram there. And that concludes everything we need to be aware of for cast diagrams. Finally, moving on now to deal with trig transformations. And we can see in this example here, we're asked to solve f of x equals cos 3x here, such that f of x is equal to a half. So what we're looking for here is cos 3x equals a half. Okay. Now this is a little bit more difficult compared to the previous example here, because we have this 3x now. So how would we tackle a problem like this? Well, we're looking for the values of x between 0 degrees to 360 degrees. So all we're simply going to do here is extend this interval 3 times as long, and then all we do at the very end is divide the solution we've found by 3. So in that case here, cos x equals a half would have these solutions here, which we can see using this graph down here. Okay, so in that case, we'd have our original or our initial solution here, which is 60 degrees. So this is 60 degrees here. Okay, so our initial solution is 60 degrees. And we can clearly use the fact that cos x is periodic about 360 degrees here to obtain our following solutions. So therefore, we're going to also have a solution at, say, 420 degrees here. We're also going to have this solution here, which is simply going to be 360 degrees minus the 60 there. Okay, so that solution is 300 degrees. Okay, so in total, for cos x equals a half then, we have the following solutions. So we have 60 degrees, 300 degrees, 420 degrees, 660 degrees, 780 degrees, and finally 1020 degrees there. However, we're looking for cos of 3x. So as we've extended the interval by 3 lots of this, in that case to find our solutions then for cos 3x equals a half, so therefore cos 3x is equal to a half, then in that case we're simply going to divide all of these solutions here by 3. Okay, so this has solutions . 60 divided by 3 giving us 20 degrees there. 300 divided by 3 giving us 100, and you can clearly see the pattern here that's being formed. Just divide each of these solutions by 3. So we have 140 degrees, 220 degrees, 260 degrees, and finally 340 degrees there. Okay, and notice as we found these solutions here between 0 and 1080 degrees, so we times this by 3, that was 0 degrees to 1080 degrees. Then in that case, as all these were between this original interval here, or the interval that we changed, then in that case dividing all these by 3 will still suffice our interval here of 0 degrees to 360 degrees. Okay, and that gives us our solutions there. And that concludes this Maths Made Easy video on trig equations.